3, 2, 1. We are live. Hello, Mike. Hello, everyone.
Hey, Caio. Hey, everyone.
Thank you for joining us. Please let us know if the video is okay. And the audio. Can you hear us? Hello?
Okay.
Looks good.
Yep.
Awesome. Thank you.
Perfect.
Alright, before we start, subscribe to the channel so you don't miss out on new live episodes. So, quick introduction. In this free series, we are covering the basics of how to build iOS apps with Swift, TDD, in a clean and modular architecture. And these free live sessions are only possible because of the students of the Essential Developer Academy. So thank you very much for your support throughout the years.
Thank you.
And if you want to take your dev skills to the next level and support our work, visit academy.essentialdeveloper.com. So this is how this session is going to work. We'll go fast, and we'll have a quick Q&A session at the end. All right? How is everything? All good?
All good, it seems. Again, a lot of excitement.
All right, so let's start. So in this season, one of the goals is to migrate the quiz app from UIKit to SwiftUI. And in the last episode, we finished migrating all the views. So here's the running app with SwiftUI. You can navigate to the questions, you can play, and play again. And by the way, there's nothing wrong with UIKit. We just want to show how easy it can be to replace UI frameworks with a clean and modular design. We did it incrementally without breaking other modules. If you haven't seen it, you can watch the previous episodes. So in this episode, we want to review the design choices, the principles and patterns we used that allowed us to easily migrate to SwiftUI incrementally. It was really, really painless. And not only the choices we made, but also design choices that Apple made in UIKit and SwiftUI. They made the code more modular and composable. And of course, we're also going to show different architectural choices we could have made and their trade-offs. I'm sure that once you see those patterns in practice, you will learn when and how to use them effectively in your own apps. Make sense?
Let's do it.
All right. The first design choice we would like to review is the abstract factory pattern. So the abstract factory is defined in the design patterns book. It says that it provides an interface for creating families of related or dependent objects without specifying their concrete classes. So let's see it in practice. Back in season 1, we decided to use an abstract factory to decouple the navigation from the ViewController creation. So the ViewController factory protocol. And we created this abstraction here because we didn't want to couple the navigation with the concrete ViewController classes. We wanted to be able to navigate to any UI ViewController. As you can see, the factory returns the base class UI ViewController, which is the abstract interface that can be subclassed in this case. So we have different implementations. For example, we created in this season the Swift UI ViewController factory implementation that returns UI hosting controllers, which is a subclass of UI ViewController. we also have the UIKit ViewController factory that returns the concrete question ViewController and results ViewController, which are also subclasses of UI ViewController. Make sense?
Exactly, yes. It creates it internally, the concrete type, but the methods return the abstract type, the base UI ViewController.
That's it. The concrete factories implement the abstract interface and return concrete implementations, or subclasses in this case, of the type defined in the factory protocol. Make sense? So that's the abstract factory.
Yes.
So clients can interact with this UI ViewController without knowing their concrete class. They can also interact with the factory without knowing the concrete implementation of the factory. And that's the Liskov substitution principle in practice, the L in Solid. Because we can provide any UI ViewController subtype without breaking the system. There was a decision that UIKit developers made where you can present any UI ViewController subclass into the view hierarchy. Because the UI ViewController is a polymorphic interface. So polymorphic. Poly, many, morphic, morph is form, many forms. Make sense?
That's it.
So that's how we were able to return different types of ViewControllers. That's also how Apple could also enable SwiftUI to integrate nicely with UIKit, with the UI hosting controller subclass. But of course, instead of an abstract factory, we could have made a factory that returns concrete types. So in season 1, we could have decided to return the concrete question ViewController here. And the results ViewController in the results API. But that would limit us to returning only those concrete ViewControllers and their subtypes. So we wouldn't be able to provide a different factory implementation returning the SwiftUI hosting controllers. Let's try to build. You're going to see the build errors. The SwiftUI ViewController cannot return the hosting controllers because the types don't match. But if we return the base UI ViewController, we can. And that's the abstract factory that enabled us to easily replace implementations at runtime. Also important to notice that the abstract factory is also a protocol, an abstract interface, a polymorphic interface that we can provide different implementations. The SwiftUI factory and the UIKit factory, or any other factory, one that mixes both, for example.
Exactly. Or other
you can
implementations.
Take many forms. Make sense?
Yep.
That's polymorphism. So the factory is also a polymorphic interface. It can take many forms or many implementations. And when you have an interface that you can replace at runtime that has many implementations, this is also called a strategy pattern. It's a common interface with different implementations or different strategies that you can replace at runtime. So at runtime, we could decide, well, sometimes we're going to return the UIKit factory, sometimes we're going to use the SwiftUI factory. For example, if you still want to support iOS 12 and before, at runtime, you can check the iOS version and either return a UIKit factory or the SwiftUI factory. Then you have two strategies depending on the OS version. Make sense?
Exactly, yes.
So that's another benefit of the strategy pattern. So clients of this interface don't need to know about the concrete implementation details. That's how we can replace them easily, even at runtime. For example, one client of this factory is the navigation router. As you can see, is one of the dependencies is the ViewController factory. So when we are navigating to another view controller, the navigation router does not create the view controllers. It asks the factory to do it. And depending on the factory you pass to it, it either is going to create the UI kit or the SwiftUI implementations. Make sense?
That's it. Yep.
Again, we could have made the navigation controller router depend on the concrete factory, like the UI kit factory. But we would lose flexibility. Because then it wouldn't be easy for us to replace that factory without changing the router. So instead of making the navigation controller router depend on a concrete factory, we made the concrete factories depend on the navigation controller router needs through this protocol. So in other words, we inverted the dependency. Instead of the router depending on the concrete factory, we created an abstraction in between, and now the factory needs to conform to what the router needs. So in other words, we inverted that dependency. That's the dependency inversion principle.
Exactly, the D in solid.
Exactly. And we used dependency injection via the initializer injection here. In the initializer, we inject the factory. So the router doesn't need to create its own factory. And that's how we can replace it easily at runtime. So dependency injection, constructor injection in this case, was crucial also to enable our system to be extended to SwiftUI without changing existing code. Make sense?
That's it, yeah.
So the abstract factory, the strategy pattern, dependency injection, the least call substitution principle, they were essential to enable this migration without breaking other modules. We just had to provide a new factory without changing existing code, which is also the open-closed principle, the O in solid. So our system is open for extension and closed for modification. In other words, we can extend the behavior of the system, can change the behavior of the system without modifying existing code. So we can change the behavior of the system just by creating a new factory and passing it to the router without changing the router, without changing any other component. Make sense?
Yeah.
And
I mean, literally created a SwiftUI version, right? It's like this is the power of these things that you're talking about. Literally created a new UI implementation, and we had no changes in the router.
That's it. And that's why design principles and patterns go hand in hand. One enables the other. Make sense? If you want to get the full benefit, you cannot just say, oh, I'm going to only follow the single responsibility principle. Or I'm only going to follow the least call substitution principle. No. They are used in unison, together.
Yes.
And that's how you get the benefits. All right, let's compile again. Oh, good. All tests are passing. All right. So let's see this abstract factory in the diagram. I think it's essential to see the shape of this pattern to understand it better.
Absolutely.
So here it is. The ViewController factory protocol returns the base UI ViewController. And then we have a concrete implementation that returns a concrete subclass of the ViewController. And that's the shape of the abstract factory. We have the interfaces here without exposing the concrete types. Make sense?
That's it. Yep.
So how we use it? For example, we need to show a question. So the navigation controller router will use the factory to return any UI view controller. And the implementation of the factory, in this case the SwiftUI factory, will create and return a UI hosting controller. But the clients don't know about these concrete implementations. They only talk to these polymorphic interfaces.
Yes.
So the router will get a view controller returned by the factory and tell the navigation controller to show that view controller. And again, the UI navigation controller, which is a UI kit class, can present any UI view controller. So here you can see that Apple also made this choice of having this base class, this polymorphic interface that allows you to extend it. So that's how you can extend UI kit without changing UI kit. Make sense?
Yes.
So this is where we stopped in the last episode. Make sense?
Yep.
And by the way, at the time when we created this abstract factory, SwiftView UI didn't exist yet. There was no SwiftView UI, only UIKit. So we didn't create this abstract factory to enable a migration to SwiftView UI. We did it because we were following good design principles, because we were trying to make our code base flexible and open for extension. And it paid off, since it allowed us to easily replace UIKit with SwiftUI. So that's the thing with design choices. Some choices don't have an immediate return, but they leave your system open for future extension. It makes your code base more flexible, so you can quickly adapt to changes. Make sense?
Yes, exactly. The old saying goes, be ready so you don't have to get ready when the new framework comes. So yeah, because the framework will come, like the changes will come. So yeah, it pays off to be a bit proactive and buy yourself some flexibility with those design choices.
Yes, software ideally should be soft, flexible, right? So how can we make better decisions if we don't know the future? We don't know the future, so how can we make these decisions? We don't know if at some point there will be a new framework after SwiftUI. How can we make these decisions? We want to keep the cost low with high returns. So how do we do it if we don't know the future? We follow design principles. That's why we have principles. For example, the solid principles were the guide for us when we were deciding to use an abstract factory. We noticed that why would we couple the navigation with the concrete view controller if we may decide to use different kinds of view controllers sometimes? At runtime, we can decide to use different types of view controllers. And it also enabled us to migrate to a new framework. So we didn't know we would need this new framework in the future, but we were trying to make our code flexible by following the design principles. So all the solid principles, the single responsibility principle, the open-close principle, Liskov substitution principle, the interface segregation principle, and the dependency inversion principle, they are all applied here. But of course, this kind of flexibility comes with a cost. For example, the abstract design here is probably more complex than dealing with concrete types directly. Make sense?
Yes.
So if you don't need this kind of flexibility, if you're creating an app that you're going to discard in 3 months,
right.
You may not want to use dependency inversion, abstract factories, and so on. If you have just a prototype that you're going to discard, yes, don't. Maybe it's not going to pay off. So this is important. We don't want you to watch this series and copy and paste what you see. Don't take this as a template to follow every time. As software developers, you are making decisions, design decisions, architectural decisions all the time. So my advice is, when in doubt, choose the simpler solution. But simple doesn't mean concrete. Although we can argue that the abstract factory can be more complex than dealing with concrete types, it doesn't mean it's complex or costly. It's not because something is more complex than other that it is complex.
Right.
The cost was very low to create this abstract factory here. It also enabled testability. It was very easy to test those components in isolation. And in this code base, we were looking for flexibility. So this was a good design choice. It paid off.
Mm-hmm. Yeah.
And it was easy to do. Or in other words, it had a small cost. And it provided high returns, the flexibility we needed. So I recommend that you accept some extra costs when they are manageably low with huge chances of high returns. For example, we accepted the small cost of an abstract factory in our design with the possibility of high returns, such as easily extending the system later on. So every decision is a trade-off. So we want to pass this knowledge forward from multiple points of view so you can make better decisions for different use cases. There is no single answer that solves all the problems optimally. If there was, everyone would be using it. And we developers would probably be irrelevant.
Exactly.
But there isn't a single solution. And that's why our profession is so valuable. Your decisions matter a great deal. It requires knowledge, creativity. And that's why you have a huge chance of making a great impact. The better your skills, the better decisions you can make, and the more you can contribute. And the software industry needs more leaders. So practice and take the lead. All right, back to the implementation. What other alternatives do we have instead of an abstract factory? A simpler way to integrate components is to use the adapter pattern. The adapter pattern. So the adapter pattern converts the interface of a class into another interface the client expects. So it lets classes work together that couldn't otherwise because of incompatible interfaces. So let's see it in practice. All right. So here we have the generic quiz engine that controls the flow of the quiz. So it goes from one question to the other question to the other question until it shows the result at the end. So the engine is generic. It's a generic module. It doesn't know about UIKit. It doesn't know about navigation. It just knows that I have a bunch of questions, I have a quiz, and I'm going to control the flow in this quiz. From the first question until the last question. Make sense?
That's it, yep.
So it controls it and sends messages outside this module through the quiz delegate generic, also polymorphic interface that in this case the router implements. So every time we get a new question, the router will present it in the UI. So the quiz engine doesn't know about navigation or UI. And the UI navigation controller, which is a UIKit type, doesn't know about the engine as well. Because UIKit is a closed source framework. So the engine doesn't know about UIKit. The UIKit doesn't know about the engine. So we need to bridge this gap between these two unmatching clients interfaces. And we can do it with an adapter. Here we did with the router and a ViewController factory, abstract factory. But we could also have done it with a simple adapter, while maintaining both sides decoupled from each other. UIKit still doesn't know about the engine, and the engine doesn't know about UIKit. The adapter would stay in between. Make sense?
Okay, yeah.
So let's show how you can convert the router with the abstract factory with an adapter. Let's do it.
Let's do it.
All right, let's have a look at the SwiftUI factory. So how can we refactor or convert this factory into an adapter. First of all, let's rename this class. So let's call it SwiftUI Navigation Adapter. Okay?
Yep.
Let's make it conform to the interface it needs to adapt. So it's going to adapt the quiz delegate. Let's make it conform to quiz delegate. And once we are done, we are going to remove the ViewController factory conformance. And then we're going to be done with the migration. Make sense?
Okay.
So we need to define, so the quiz delegate is a generic protocol. So we need to define the question and answer types. In this case, the question is question of string. And the answers is just an array of strings. Make sense?
Yes.
But to avoid conflict with the name question and question, let's give it the module name quizengine.question. And we need to replace occurrences of question string with the type alias question. Make sense?
Yes.
All right, replace. There you go. You can also replace occurrences of array of string with the type alias answer. Replace. All right. And the quiz delegate defines two methods we need to implement. The answer for question and did complete quiz. Make sense?
Yep.
The types match here, answers. So let's use the type alias. It's more readable. All right. So far, that's it. Let's compile to see if the types are all correct. Yeah, the test still pass. Let's carry on. So here in those methods, we need to navigate to the view controllers. Make sense?
Yes.
So we need a navigation controller. So the navigation adapter will adapt the messages that we get from the quiz delegate and translate it to messages to the UI navigation controller. That's the adapt functionality. All right, so we need a navigation controller in this adapter. So let's start by changing the tests. Also, the test now, instead of a factory test, is an adapter test. SwiftUI navigation, navigation.
Yeah.
Adapter test. All right. So here, where we create the SUT, the system under test, let's also create a navigation controller. And let's inject it into the factory. Or the adapter now.
Right.
Of course, we cannot build because the adapter doesn't receive yet the navigation. So we can add here navigation as a dependency, navigation controller. Make sense?
Yes.
Let's also capture it.
Okay.
Fix the build errors. Now in the composition, when we create an adapter, we need to pass a navigation controller. And we do have a navigation controller. So navigation controller. Make sense?
That's it.
Let's run the test. Should still pass because we're not doing anything yet. All right, passing. So now we have a navigation controller and we are implementing the quiz delegate. Now we just need to navigate to the question view controllers and to the result controller in the different delegate methods. Make sense?
Exactly. Yes.
All right. Let's start with a test then. So adapter test. Let's add a new test here. Test. First method is answer for question.
Mhm.
So test answer for question. It should push us questions to navigation stack. Make sense?
That's it.
So we need the system under test and the navigation.
Okay.
So we can assert in the test. So make SUT. Make sense?
Yep.
So the make SUT now, instead of returning just the adapter, it can also return the navigation controller. We could also create another factory method, up to you to decide. So here, let's return SUT and navigation as a tuple. All right. Let's update the other tests that use the tuple. In this case, we don't need a navigation. So let's just use underscore. We don't need navigation yet, but we will soon. Okay, run the tests. Passing. Let's carry on. Now we need an assertion.
Okay.
First of all, let's call the method answer for question, and we have the single answer question. And we can also call it for the multiple answer question.
Mm-hmm.
And what should happen here? We are pushing the views to the stack, which means at the end, the navigation stack, navigation, view controllers, stack, count should be 2. 1 for
That's
each
it.
question. Make sense?
Yeah, exactly. That's it.
So let's create another assertion, also to check the types in there. So we can say assert true. The first view controller should be a UI hosting controller in the SwiftUI factory. And the root view type should be a single answer question. Make sense?
Yes.
And the last one should be a multiple answer question. So we should have 2 view controllers in the stack, one for the single answer, the first one, and the last one for the multiple answer. Make sense?
Yep.
Let's run the tests.
Okay.
Failing, of course, because we're not doing anything here.
Yeah.
So let's make it pass. First, let's create a controller, and we can use the helper methods here. Question view controller for question. Answer callback is the completion. And we can call navigation push view controller animated true.
That's it.
Run the test. All right, still failing, but we had 3 failing tests, now we have only 2. So the first one worked. It presented the first view controller, but not the second one. And that's because we are pushing the view controllers with an animation. Animated equals true. So the navigation stack update may not run synchronously. It will update at some point in the future because of the animation. Makes sense?
Yeah.
We showed how you can deal with this in season 1. So let's have a quick recap here. One way to bypass this waiting time is to run the run loop explicitly. So run loop current run until date. Just force the run loop to run. And that should make the test pass. We don't need to wait for the animation. Boom, there you go. But I don't like this run loop trickery in our tests. Another way we can do it is to use a spy test double. Let's remove the run loops. Let's see the failing test again. All right, now let's create a test double, a spy test double. So in this case, we can create a navigation controller spy. So navigation spy is a subclass of UI navigation controller. And we can capture in the spy all the messages it received. So push messages, it can be an array of messages. So let's see the type of the type signature of the push view controller. It gets a view controller and the animated property. So we can capture all the view controllers received and the animated.
That's far before push messages. Yep.
Make sense? So now we can just append the received view controller and animated Boolean.
That's it.
Make sense?
Yes.
So the spy, every time it receives a message, it appends it to this array. So in the test, we can check now, instead of check the navigation stack, we check the push messages. So we should have received 2 push messages. The first one, view controller, should be the single answer question. And the last one should be the multiple answer question. Make sense?
Yes.
We just need to update the make SUT to create the spy now. Create and return the spy. Let's run the tests. Passing. And if we change the implementation, if we do the wrong thing here, it fails. With a spy, you can also check if the call was called with animated true, if this is important to your use case. So assert equal, animated should have been true. In the last case as well. Let's run the test. Boom, passing. Make sense?
Yes.
So if we change this to false now, by mistake, the test fails. Fantastic. So the problem with spies is that it couples your tests with the production implementation. Or it couples more with the production implementation.
Yeah.
And sometimes you want that, right? But sometimes you don't. So there's yet another way, which is to use a fake test double. So let's undo those changes. Instead of using a spy, we can use a fake navigation controller, which is another type of test double. We use one in the navigation router tests. Here. In season 1, we created the non-animated navigation controller, which is a working navigation controller, a fake one that ignores the animated property and always animates as false. Thus, we don't need to wait for the animation. Make sense?
Yep.
So we can also use it here. No animated view controller. So it still pushes it to the stack, but it overrides the animated property. Make sense?
Exactly, and which doesn't interfere with the test, so thus we're passing.
That's it.
Awesome.
So I find the fake test double the simplest and often the most stable solution. It doesn't require the run loop trickery or more complex spies. But again, sometimes the SPI will give you more control at the cost of more coupling between the test and the production implementation. So choose with care. When in doubt, go for the simpler solution.
That's it.
Make sense? That's
Yep.
it. 3 options to test the navigation. Right, let's also add a test for the result API. So did complete quiz with the no correct answers. Let's call it twice to prove that we are pushing. So did complete quiz pushes result to navigation stack. And the result view is the type for the result API. Make sense? If we call this twice, we should have 2 view controllers in the stack.
That's it.
Let's run the tests. Should fail. Failing. Let's implement it now. Similar to this one. But now we're going to create result view controller for answers. Answers. Run the test. Passing. Can even create a helper method here, like show controller. Now we just call show in one line. What do you think?
For both. Yeah, I like it.
Run the test again. Passing. Now we can replace the factory with the adapter in the composition. Let's see. App delegate. So instead of creating a factory in the router, now we create the adapter. We don't need the router.
Fantastic.
Anymore. The adapter will do the navigation directly. So we pass the adapter, because the adapter now conforms to the quiz delegate. Make sense?
Exactly.
Run the test. Passing. Let's run the app. Still works. Pushes. Can play again. Make sense?
Yep.
So now we can remove, finally, the ViewController factory implementation. Or the conformance. Let's run the tests. Passing. So I would like to make the factory methods private. 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 The show function can also be private. Implementation details. So we need to update the test now. So the test helpers were using the factory methods. But now they can get the ViewController directly from the stack. So we get a navigation. We call SUT answer for single answer question with the completion callback. And we can extract the ViewController from the stack. Top ViewController. Make sense?
That's it, yes.
So we can do the same thing here. So we execute the function that has a side effect that pushes something to the navigation stack. And then we can capture the navigation controller, or the ViewController in the navigation controller. That should be in the top of the stack. And we already have a test to prove that it is pushed to the top of the stack. Make sense?
Fantastic. Yes.
And the last one, navigation. We call the method with side effect. and we extract the top view controller from the stack. Let's run the tests. Passing. We fully migrated
Beautiful.
the abstract factory to an adapter. Let's commit. Replace Swift UI abstract factory with navigation adapter. So let's have a look at the diagram now. So we had an abstract factory. Navigation router would use the ViewController factory to create view controllers. Now we only have a navigation adapter that will create in the hosting controllers and use the navigation controller directly to show that view controller. So we eliminated two components here. The factory protocol and the concrete implementation. So you can say that we simplified the design. Less components, simpler design. Make sense?
Yes.
By the way, I learned how to replace abstract factory with an adapter in the book Dependency Injection, Principles, Practices and Patterns by Mark Seaman and Steve Van Dorsen. I highly recommend that you read it.
Definitely.
Gonna learn a lot. All right. Let's run the app again. Still get the push. Fantastic. It's working. Makes sense so far?
Yeah.
And in the new Swift UI layout flow, let me open it here. We don't want the back button anymore. You should only go forward. No way to change the answer. So we can change the logic to replace the stack instead of pushing view controllers into the stack. Make sense?
Yes.
So let's update the test. First of all, the test name, instead of pushes, should be replaces.
Yeah.
Navigation stack.
Yes.
Make sense?
Exactly. That's exactly what happens. Yes.
So when we present the first one, we should have one view controller. Make sense? And when we present the multiple answer question, we should also have one view controller only in the stack. We are replacing the stack with the multiple answer question. Make sense?
That's it.
The same thing here. When we present the result view the first time, and then we present another one, we should have only one in the stack. So we are replacing the item in the stack. Make sense?
Yep.
Run the tests. Should fail. Boom, failing. We have two items in the stack because we are pushing.
Yep.
So adapter, implementation. Now we can replace the stack. And we can replace the stack with the set view controllers API. We can replace the stack with a new stack. In this case, with only one item. And we can do it with animation as well. Let's run the tests. Whoops, failing.
Because
what is wrong here?
count one.
Should it be first?
Let's try
Should
first.
be the
Yes.
same. You have only one item in the stack. Ah, we need to update our spy, remember?
Right, of course.
Because now we're using a new API.
Classic.
Not the spy,
Yes.
the fake. No animated.
The fake, yes.
So set view controllers.
Push.
to call super set view controllers animated false. Let's run the tests. Boom. Passing.
Okay. Let's just update quickly the name at 106. That's yeah.
Replaces navigation stack.
That's it.
Run the test. Passing. Let's commit. Replace navigation stack instead of pushing controllers. Make sense?
Yep.
So that's it. That's a different way of implementing a flexible design by using an adapter. But it's important to notice that creating the view controllers and showing the view controllers now leaving the same component. So we are creating the controllers and showing the controllers in the same component. So the creation and navigation is somehow coupled with an adapter. Make sense? We can't change the controller type without changing the adapter. And we can't change the navigation without changing the adapter. So we lost a bit of flexibility with an adapter. In this case, it can be okay because we don't want to ever go back in the questions anymore. We only go forward. But what if we change this requirement again? And sometimes, let's say we have an easy version of the game where you can go back and a hard version of the game where you can only go forward. Then we need a little bit more flexibility. Make sense?
Yeah.
One way of doing it is to pass a boolean here, is easy.
Right.
And here you check, if is easy, do push. If it's not easy, set the view controller stack. But that's very procedural. That's not object-oriented at all. It would be best to have a polymorphic interface that we can replace the runtime. Make sense?
Yes. Yes, exactly.
So if you want to be able to change the navigation without changing the adapter, we can inject the navigation logic into the adapter. For example, we can use a protocol or a closure, a simple closure. Make sense?
Yep.
So we can replace this dependency, the navigation controller dependency, with a closure, like show. And here we can pass a show UI view controller. Instead of passing navigation, we pass the show closure. Show equals show. And we don't need the show method anymore. So we are injecting this logic. So show now is calling the closure and passing the navigation controller, the UI view controller. Make sense?
Yep.
So now in the composition, we can inject here, instead of the navigation controller, we can inject show. Make sense?
Yep.
And here we can call navigation push view controller animated true. Let's run the app. And now we have the push behavior. And we can also set the stack. View controllers. Let's replace the stack with a new stack. And now we don't have a back button anymore. You can only go forward. Make sense?
Yep. Really neat.
We could even present it modally. Present the view controller animated. Look at that. It's a modal now. But we cannot present a modal twice in the same view controller until this modal is released. But we can create a simple API to get the top modal. Private extension UI view controller. Top modal UI view controller. So if we have a presented view controller, we try to get it stopped modal, like recursively. Otherwise, we return self. Let's see. Run. Boom, we can play now with modals instead of navigation.
Fantastic.
We gain much more flexibility, still using an adapter. Make sense?
Yeah.
And we can go back by dismissing the modal.
Yep.
If you don't want to go back, we can even set the ViewController presentation modal presentation style to full screen. Boom, you cannot go back anymore. Only forward. And so on. You gain a lot of flexibility by doing so, by injecting the navigation logic. And that's the strategy pattern. A common interface with multiple implementations or strategies. And here we could inject different strategies depending on the game type, easy or hard. Make sense?
Hello?
Hello? Can you hear me?
Hello?
Yeah, I can hear you.
Okay. Yeah, I can hear you now. Fine.
All right. So we were talking about the strategy pattern that defines a family of algorithms, encapsulate each one, and make them interchangeable. Make sense?
Yeah.
We can change the strategy without changing the client. So we went from the adapter, dealing with the navigation directly, with an adapter, plus the strategy that we inject with a closure in this case. In the closure, we use the navigation controller or some other form of navigation. Make sense?
Yes, exactly.
So in this case, the polymorphic interface is the closure, because you can inject different implementations, multiple implementations. Make sense?
Yeah, exactly. And when you have just a single closure, you can use a closure instead of a protocol, for example. You don't have to wrap everything in the protocol, right?
That's it. By the way, we could have done the same in the navigation router. Instead of navigation router actually talking directly with the navigation controller and pushing, we could inject the navigation logic as well. Make sense?
Yep.
So when you need this kind of flexibility, you decouple your component from the action it needs to perform with a polymorphic interface, such as a protocol or closure. Does it need to pass a boolean and have procedural code? Because then what if you have 3 game types?
Exactly.
Easy, medium, hard. Then you need to add another boolean or add an enum with 3 cases.
So everywhere you use suites, no, that's not the way.
And if you add a very hard case, now you have 4 cases.
Yeah.
It's easier to just inject different behaviors with a polymorphic interface. Make sense?
Yeah, yeah.
So you can change the behavior without changing existing code. It's easier to test as well. Because every time you add a boolean, you need at least 2 tests. And if you have 2 booleans, you need 8 tests. And 4 booleans, 16 tests.
Just use a polymorphic interface, don't go down that road.
But again, if you don't need this flexibility, if you know, no, this navigation will never change, you can simplify the design by coupling the component with the concrete algorithm. Make sense?
Exactly. I think the most important thing maybe you need to take away today is what you said before. Don't follow this blindly. Just learn these things and learn when and how to apply them. There's no one solution for every case.
You will depend on your use case. Exactly.
Yes. So we have all these tools here, so you can solve all kinds of problems. Your problems,
Exactly. Don't take this as a template. Copy and paste.
Yeah.
Make sense? So let's have a look at the final diagram. So before, with the abstract factory, we had this routing layer, but we replaced these three components with a single adapter. So we don't even have the routing layer. So we can argue that this is a simpler design.
Yeah.
And we can inject the navigation behavior if we want to. Otherwise, we just do it directly in the adapter. Make sense?
That's it.
Of course, as you've seen, all the solutions we presented in this series is 100% testable. Every solution is testable. We test drive it, which make them testable from day one. Make sense?
Yeah.
So that's it for this live session. We covered some essential design choices, principles, and patterns that helped us create a modular design in our quiz app. And as a benefit, those design choices enabled us to migrate to SwiftUI seamlessly. In fact, we can still run the app with the old UIKit implementation. Let's go back to the composition. So we can just recompose those objects and run the app with UIKit. For example, we can create a UIKit factory with the options and the correct answers. And then we can create the navigation router with the navigation controller and the factory. And we inject the router instead of the adapter. Let's run. Look at that. It's running the UIKit version now. Make sense?
Yep.
With the submit button at the top and so on. And we can replace it with the adapter here, change the composition and change the application without changing existing code. Look at that. Make sense?
Beautiful. Yes.
So that's it. That's the power of a clean and modular architecture. So we hope this session helps you better develop, test, and maintain your code bases, and also help you migrate to SwiftUI incrementally if you so wish. We show that this strategy pattern can also enable you to provide a UIKit and a SwiftUI implementation, so you can still support old iOS versions. And of course, the solution shouldn't be taken as a template to copy and paste. The idea is that you learn how to make good design choices on your own, so you can solve your own challenges optimally. And there's so much more we are going to cover in this series. So subscribe now and don't miss out on future episodes. Now, quick Q&A. Do we have any questions in the chat?
I believe we do. We have some questions. First of all, let me say we have some new faces. Welcome, everyone. Some names, rather, not faces. So, how about Mac apps that don't use UI view controllers? I believe that refers to the view controller factory.
Yes, Mac apps, they have a different user interface. They wouldn't work with UI view controllers.
Exactly.
But they work with SwiftUI.
Yeah. I mean, and you can also build abstractions upon abstractions if you want that sort of flexibility, but maybe SwiftUI is the way to go here.
Mm-hmm. You can use generics as well.
Absolutely, yes, exactly.
So you could make the view controller factory even more generic with a associated type, probably, like a controller. That was not our goal with this code base, to run the same view controller with different platforms.
Yes.
Our idea is that if we have a new platform, we will create a new UI module, a new composition, and that's it. We're going to reuse the presentation and the engine. The presentation and the engine and the scoring modules, they are platform agnostic. They can be used in any platform. But the UI is platform specific. It's UIKit and now SwiftUI. And the main module is application specific. So a Mac application will have its own main module with its own composition root that will create the types necessary to compose all the modules together for the Mac app application. Make sense?
That's it, exactly.
And if you have a watchOS application, you have another composition root and probably another UI implementation, but you reuse all the other modules. Make sense?
That's it.
All right.
Mike asks, does Solid apply to reactive Swift?
Absolutely. Solid is, they are design principles. They apply to any language.
Functional, paradigms.
Any paradigms, exactly. There are more,
you can see,
there is more literature about it in object-oriented programming, but they are principles, they're design principles that you want in software in general, not just in paradigms or languages or features. You want your modules to be decomposed from each other, so you can compose them, reuse them, test them in isolation, and so on. And those are the principles, the solid principles define some guidelines to help you achieve the modularity. Make sense?
Yes. Yeah. You can see a bunch of stuff in the course as well about this topic that we go through.
Marcelo?
Next question. Yeah. Could we use the builder pattern instead of the factory pattern? Sorry.
No.
In this case, for the ViewController factory?
Probably not, because the builder pattern is used to create complex objects that you want to create an object step by step. For example, when you're creating a URL, it's quite complex to create a URL. You need to set the path, you need to set the host, you need to set the base URL, and so on. There are multiple steps. And when there's multiple steps to create a complex object, you can use the builder pattern. So you can literally step by step create their object. But here we create a ViewController. We don't need multiple steps to create the ViewController, right? We have all the data we need.
Exactly.
Thus, I wouldn't use the builder pattern here.
So you could just swap to the router if you're running before iOS 13? I believe that's true.
See.
I understand correctly.
So in the composition here, you could add some logic like if, what is the syntax? Available?
I think so.
iOS. I don't remember the syntax, but you can check here.
Yeah, let's
availability. See. If iOS 13 plus, you do this. Else, you use the old UIKit implementation, something like that. I just don't remember the syntax. Make sense? That's one way you can do it. But then you have two implementations to maintain. Maybe that's not the way to go if you have a massive app. All right.
Okay. The most classic question ever received. What is the program that you're using to make the diagrams? It's draw.io. It's the website we use.
Draw.io.
Yeah. And Harry asks, shout out to Harry, by the way. We mentioned him in the last live as well. Congratulations on your job, a new gig. What book would you recommend to read first out of all your suggestions?
Depends.
Say there. Yeah.
What do you know already?
There's no particular order, so.
I really like the Dependency Injection book. But depends. If you are a beginner, if you've been programming for just a few months, maybe it's going to be too advanced. So I believe the Clean Coder, probably. What do you think, Mike? Clean Coder or Clean Coder?
They're all good. I don't know. Just read them all.
Read the Apple Swift book.
Yeah, that's the first one for sure, actually.
And if you're a Swift developer, you should read the Swift book. It's free.
I read the Clean Coder, I think, back in the day first, and it made the impact. I don't know.
All right. How would you deal with API available in different iOS versions to avoid having available checks everywhere in your code? Move this check to the composition root. That's it.
Okay.
All right. I think that's it.
Yeah.
Good recommendations for pro-con list around reactive programming. Yes, we have mentoring sessions about reactive programming. Have a look. Is there a standard definition for the style used in diagrams? Yes, we're following a subset of UML.
Yeah.
Make sense?
That's it. Yeah.
Study UML if you want to learn more. The colors are just our choice. Don't focus on the colors.
Yeah.
But the arrows here, they all have a meaning. The dash lines, the solid lines, they all have meaning. All right. That's it. That's it for this live. If you want to take your dev skills to the next level and support our work, join the iOS Lead Essentials program. There's a new cohort starting soon. Learn more at academy.essentialdeveloper.com. And if you enjoyed this session, like the video and subscribe to the channel now so you don't miss out on new live episodes. So thank you for watching, and we'll see you again next time.
That's it. Bye, y'all.
See ya.